I'm Michelle DeFrangia, Assistant Editor of Design World.
And I'm Lee Teschler, Executive Editor of Design World. And Michelle, today our discussion starts with this little component here.
The phone charger?
This is a charger for a smartphone, actually.
Oh, okay.
Now, that brings up another subject. Are you old enough to remember when cell phones were clamshell phones?
The flip phones?
The flip phones.
Yes, my mom's old cell phone, actually, she saw in the Smithsonian the other day. So she's had every phone from from the car phone to everything. So I've seen them all.
Your mother's phone. Okay. Well, the reason I bring that up is that chargers like this for smartphones are a larger wattage than the chargers for the older generation phones.
Why is that?
Well, because there's more going on in a smartphone, basically. But the chargers for the more modern phones and tablets can hit 15 or 20 watts, and they're using higher currents than the older chargers simply because everybody wants fast charging and because there's just more going on in the phone. Consequently, you're likely to find a fuse in the input circuit of a smartphone charger. That brings us to this device. It's a 777 series fuse designed by Littelfuse, and it's specifically designed for chargers that provide these higher wattages. A point to note about this thing is that it needs to open up when there's a short circuit, but it also has to not open because of momentary charges or pulses, which can happen in normal operation for a variety of reasons.
Would that be like a surge, like if there's an electronic surge of some sort?
Exactly.
Okay.
And in fact, there's actually an IEEE standard for characterizing these types of surges. And that's why Littelfuse designed this particular device to withstand up to 24 hits of a 7.5 kilovolt ringwave surge, as IEEE defines it, without opening.
That's a big surge.
Well, that's a lot of voltage, and you wouldn't want to be holding this if it got hit with that.
Definitely not.
But the fuse still opens safely on a direct short circuit without exploding or otherwise producing soot or sparks or that kind of nasty stuff. One point to note is that you can't select a fuse just based on the normal operating current and ambient temperature. On that subject, we should probably say that there are several parameters that come into play when you specify a fuse, but we're going to talk a little bit about one particular fuse parameter called the I²T rating. It's measured in units of amperes squared seconds, and it's basically the amount of energy necessary to melt the fuse element. Now,
what do you mean by melt the fuse element?
Well, when a fuse opens, basically it melts.
Okay.
It's no longer, and it opens the circuit that way. To understand I²T, it's helpful to know how a fuse manufacturer measures it. Basically, the procedure is to apply a pulse of current to the fuse for 8 milliseconds. If the fuse doesn't melt, you boost the level of current. They keep doing this until a fuse element melts within about 8 milliseconds. The purpose of keeping the current pulse down to a short burst like this is to make sure the heat it creates doesn't have time to thermally conduct away, and that all of it goes into actually melting the fuse.
Okay, so I have a question. So with these new chargers, I don't know if you've seen, but a lot of them now have 2 USB ports, so you can charge 2 things at once. Will this be able to handle that amount of current, or will you need something else?
Now, that's one of the reasons they came up with this, is because the chargers are actually pulling more current as they would in that case if they were charging 2 devices. That's another rationale for coming up with this particular fuse. Once the measurements of current and time are determined, it's a simple matter to calculate what's called the melting I²T. That's the parameter you generally see listed in fuse data sheets for I²T. Once the fuse material melts, an electrical arc happens just before the fuse opens. So there's also an arcing I²T that refers to this time period, which is pretty short compared to the melting I²T. Finally, we should say that the 777 series is relatively small. It's a little less than 3/8 of an inch long, officially 9 millimeters long, and it is in what's called an axial-radial leaded package because it has leads instead of surface mount pads. Of course, there's a lot more to the 777 series that we haven't touched on here. You can get more details by downloading the Fuseology Selection Guide at speedtodesign.com.